Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. In this tutorial, we're going to go over resistors in parallel. In the last one, we covered resistors in series and talked a bit about Ohm's law. The way you do resistors in parallel is different than the way you do them in series. You remember that when they were in series, if I put two resistors together like this, you added the values together, and that was the resistance of the circuit. In parallel, it works just a little bit differently. Instead of adding them up, you do some division. For today, I have a circuit set up that we can measure up to 3 resistors in parallel. The circuit will feed the positive side, goes through this positive rail, goes through each amp meter, through the resistor and down to ground. With this circuit, whatever I put in between these two pins will get the full 30 volts applied to it. In the last tutorial, where they were set in series, the voltage was divided amongst the resistors, so no one resistor would get the full 30 volts. With one resistor in, though, it will get the 30 volts, and if you remember the way we would calculate current, it would be voltage divided by resistance, or 30 volts divided by 1,000 ohms. These are 1,000 ohm resistors, which would be 30 milliamps. I'm going to go ahead and start the simulation just to verify that we get what we expect to get. These all read 0 because there's nothing there. This reads 30 milliamps, which is exactly what we'd expect to get. When I stop the simulation, I'm going to move another 1K ohm resistor in there. Both of these are going to get 30 volts. At this point, you might want to pause the video and just think about it for a minute and come up with an opinion as to what you think the result will be. With both resistors in place and both resistors getting 30 volts, they each have 30 milliamps flowing through them. The power supply is delivering 60 milliamps total, which is what we would expect to get through each one. Now, if you were to calculate the total resistance of the circuit, you would take 30 volts and you would divide it by 60 milliamps, and that will give you the resistance of the circuit. So 30 volts divided by 0.06 is 500 ohms. So the total resistance of the circuit is 500 ohms. I used 1K or 1,000 ohm resistors on purpose to make the math easy. But what you do when they're the same is you just take the total number of resistors, which is 2, and you divide it by the value of the resistor. So if you have 1K ohm and 1K ohm, divide it by 2 and you get 500. I'm going to stop the simulation and add another resistor. I'm going to add a third 1K ohm resistor. In this case, you'll see you'll get 30 milliamps, 30 milliamps, 30 milliamps, and a total of 90 milliamps. And if we use our calculations, there's 3 resistors, and they're 1K ohm. You take the 1K ohm, you divide it by 3. So you take 1,000 ohms, divide it by 3, and our total resistance is 333 ohms. 30 volts divided by 333 ohms is equal to 90 milliamps. That should make sense. If each one of these is drawing 30 milliamps, add them all together, your power supply should be delivering 90 milliamps. So we'll go ahead and start the simulation just to verify what we've got. And as you can see, we have 90 milliamps, and each one is drawing 30. Now I'm going to take this first 1K ohm resistor out, and we're going to replace it with a 10,000 ohm resistor. Now the 10,000 ohm resistor with 30 volts delivered is going to, instead of drawing 30 milliamps, it's only going to draw 3 milliamps. So we'll get 3 milliamps, or 30 milliamps, 30 milliamps, and 3 milliamps for a total of 63 milliamps. And that's what we get, 63 milliamps, 3, 3, and 3. Now if we use our calculator again, we can figure out what the resistance of this circuit is. We take 30 volts and we divide it by 0.063. Remember, 1 milliamp is 0.001 amps. And we get 476.19 ohms of resistance. Now, in order to calculate the resistance on paper of this without having the milliamps, I'm going to switch the video and walk you through how to calculate it. The way you calculate resistance is you take each value, you take the reciprocal of it, and you add it together. We have 1 over 1,000 plus 1 over 1,000 plus 1 over 10,000. That equates to 0.001 plus 0.001 plus 0.0001, which equals 0.0021. Then you take that value and you get the reciprocal of it, and you get 476. And if you remember, our calculated value was right at 476 ohms. Now we're going to go through and do the other two examples from earlier on. We're going to go back to the two 1K ohm resistors in parallel. You take the reciprocal of 1,000 and add it to the reciprocal of 1,000, and you get 0.001 plus 0.001, which equals 0.002. You take the reciprocal of that and you get 500, which is the same as taking a 1K ohm resistor and you dividing it by the number of 1K ohm resistors you have, which is 2, and you get 500. Now we're going to do the three 100K ohm resistors together, and you get 0.001 plus 0.001 plus 0.001, which is equal to 0.003. You take the reciprocal of 0.003, you get 330 ohms. And that completes this tutorial on resistors in parallel. Thanks for watching.